guys, and welcome back to the PyTorch tutorial series. This is going to be our first section, which is known as the PyTorch basics. And in this video, we're going to talk about the difference between scalars, arrays, and matrix. First, before we see the difference between a scalar, arrays, and matrix, let's start our discussion by defining what is a tensor. The inputs, outputs, and transformation within neural networks are all represented using tensors. As a result, neural network programming utilizes tensors heavily, and a tensor is just a primary data structure used by neural networks. So you might have already learned about tensors when learning about different other deep learning frameworks such as TensorFlow. That's where the name tensor comes from. And a tensor is just a mathematical representation of a data structure such as arrays, vectors, and other higher dimensional arrays. And PyTorch also utilizes tensors to build different kinds of data structures. Now, let's talk about the specific instances of tensors. Each of these examples are specific instances of the more general concept of a tensor. We might have a number, scalar, array, vector, 2D array, and matrix. So let's organize the above list of example tensors into two groups. The first one is numbers, arrays, and 2D arrays. And the second group includes scalar, vector, and matrix. So in computer science, we use the terms number, array, and 2D array in order to represent different dimensional arrays. And in mathematics, we use a different term such as scalar, vector, and matrix. So the title for this video, the scalar, vector, and matrix, is just the mathematical name of these data structures. And the first group of three terms are terms that are typically used in computer science, while the second group are terms that are typically used in mathematics. Now, let's talk about the indexes required to access an element from these data structures. Once we group these data structures into different groups, depending on the context of where they're used, the relationship within each of these pairs is that both elements require the same number of indexes to refer to a specific element within the data structure. So for example, in order to access a single number or a scalar, we just we don't need any indexes, so the number of indexes required to access any element from a number or a scalar is 0. And in order to access an element from an array or a vector, we need 1 index. And in order to access elements from a 2D array, we need at least 2 indexes, one which enables us to access across the row and another through the column. So in mathematics, we stop using words like scalar, vector, and matrix, and we start using the tensor or ND tensor. So previously we have mentioned that we use the word tensor, especially in mathematics, to represent higher dimensional vectors. So we stop using the terms scalar, vector, and matrix as the number of dimensions increase, and we start calling it an ND tensor. The N in the ND tensor tells us the number of indexes required to access a specific element within the structure. And in computer science, we stop using words like number array, 2D array, and we start using the word multidimensional array or ND array. So when you use packages such as NumPy, you usually use an ND array. and the n tells us the number of indexes required to access a specific element within the structure. So let's group all of them together for higher dimensional vectors, and higher dimensional vectors within dimensions are going to be called ND array in computer science and ND tensor in mathematics. And the number of indexes required to access the elements is going to be replaced by the variable n. So for example, if you have a 4-dimensional array, so you can call it a 4D array or a 4D tensor, and you need at least 4 indexes to access all elements. Let's make this clear. For practical purposes in your network programming, tensors and ND arrays are one and the same. So tensors and ND arrays are just different terms to explain basically the same thing. So tensors are multi-dimensional arrays, or ND arrays for short. The reason we say a tensor is a generalization is because we use the word tensor for all values of n, like a scalar is just a 0-dimensional tensor, a vector is just a 1-dimensional tensor, a matrix is a 2-dimensional tensor, and an ND array is just an n-dimensional tensor. So tensors allow us to drop these specific terms and just use an n to identify the number of dimensions we're working with. So specifically when we are working with PyTorch, we're going to use tensors, and we're just going to name them as 0, 1 to n-dimensional tensors. And we drop the terms like scalar, vector, and matrix in order to avoid any kind of confusion. And later on, we can see that we can go back and forth between an ND array created using a NumPy and convert it into tensors. So all of the operations that we're going to implement for this course are going to be basically worked on tensors. And if you have created an ND array using NumPy, you have to convert them into PyTorch tensors before you start performing other operations. Next, we will use the Jupyter notebook in order to implement some of these ideas. Welcome back, guys. This is a notebook that we have already created in the previous video, and if you haven't watched that video, I advise you to go and watch it now. We have already incorporated our newly created virtual environment here, and we're going to start section 1, which is the scalars, arrays, and matrix. As I mentioned before, a scalar is just a number, and a vector is just one number, and here we have 1 dimensions, and a matrix is a 2-dimensional vector, and a tensor is just a name that expresses higher dimensional vectors. And here first we're going to create a simple list, a Python list, and we're going to put 1, 2, 3, 4 and assign it to A. So suppose we have this array, and it's just a simple vector, and then we're going to be accessing a single element from this list. And in order to access a single element from a vector, which is a one-dimensional list, we're going to use the index 2, and as we can see here, we can access 0, 1, 2, index 2, which is 3, as an output. And here we have another 2-dimensional vector, and this is a matrix, and it's going to be a list of lists, and it's composed of 3 lists, and this is the first row, the second row, and the third row. In order to access a single element from a 2D array, we can use 2 indexes, as we have mentioned on the slide. And accessing using 2 indices, we have to access the row first in the first dimension, and then we have to access in the columns. So row first and column second. So let's say if we want to access an element from the first row, we use the index 0. The second row will be 1 and the third row will be 2. Now we're accessing the first row, so we're going to use 0. And since we want to access the second element, now we go through the second dimension. So this is going to be 0, 1, 2, and we have an output of 3. And finally here we have just a scalar, and a scalar is not just going to be a list, it's just a number, and this is just a scalar, and we can just assign it to the variable a and output the result. Now this is all about scalars, arrays, and matrix. In the next video we're going to go deep and discuss the next section about rank, axes, and shape, which is associated with these type of data structure. Once we understand this concept, we're going to create a tensor using PyTorch. Thank you for watching, and see you in the next video.
Audio Jungle.